The last thing we need to do with rational expressions is worry about equations and functions with them. First, let's look at equations. Say we have an equation containing a rational expression, like 1 plus 2 over x equals 9. The first step to solving an equation like this is to make sure that the left and right sides are both a single fraction. Let's combine the two terms on the left side. 1 can be written as x over x. So we have x over x plus 2 over x, which is equal to x plus 2 over x, which can't be simplified. So this is the left side, x plus 2 over x. And on the right side, we have 9, which can be written as 9 over 1. This gives us an equation which looks like a proportion. So to solve this, we can cross multiply. If we multiply x plus 2 by 1, on the left side we'll have x plus 2, and if we multiply x by 9, we'll get 9x on the right side. Now if we subtract x from both sides, the left one will cancel, leaving us with 2 is equal to 9 minus 1, which is 8 times x. If we divide both sides by 8, we'll get x equals 2 over 8, which is equal to 1/4. Unfortunately, even though we solved this equation and figured out that x equals 1/4, 1/4 isn't necessarily a solution. Notice that in this step, from the second line to the third line, we multiply both sides of the equation by x. However, we can only do this. In fact, the equation only makes sense if we know that x is not equal to 0. Otherwise, taking 2 over x would be undefined. This means that had we solved the equation we got after line 3 and figured out x was equal to 0, that wouldn't be a solution even though it looks like one. Let me show you an example where something like this actually happens. Suppose we had the equation 2x plus 3 divided by x plus 1 is equal to 1 plus 1 over x plus 1. Let's try to solve this equation. First, on the right side, we can combine the 1 and the x plus 1 into x plus 1 over x plus 1 plus 1 over x plus 1, which is equal to x plus 2 over x plus 1. Now we have fractions on the left and the right side. Now the next step is to cross multiply. But notice how x plus 1 is the denominator in both the left and the right side. So we can simply cancel them out by multiplying both sides by x plus 1. This will give us 2x plus 3 equals x plus 2. If we subtract x from both sides, we'll have x plus 3 equals 2. And then subtracting 3 from both sides, we have x equals 2 minus 3, which is minus 1. But if we try plugging minus 1 back into our original equation for x, then we'll see that both sides are actually undefined, so the equation doesn't even make sense, since x plus 1 would be 0. Since this was the only value we found for x, this means the equation we had has no solutions, and minus 1 is what's called an extraneous solution, as you might have already guessed. So it's important to watch out for these whenever dealing with rational expressions and solving equations. Now to better help you understand what's going on here, I'm going to divide 2x plus 3 by x plus 1 using long division. So we write it out like this, and x plus 1 fits into 2x plus 3 twice, so we get 2x plus 2, since 2 times x plus 1 is 2x plus 2, giving us a 2, and subtracting here we get 0x plus 1, so there's a remainder of 1. Now this means that 2x plus 3 over x plus 1 is actually equal to 2 plus 1 over x plus 1. So our equation actually says 2 plus 1 over x plus 1 equals 1 plus 1 over x plus 1. Now you can see how these 1 over x plus 1 terms would cancel by subtracting them from both sides, leaving us with 2 equals 1, which is impossible. Here we've solved the equation without multiplying by any expressions containing x, which means that we did not produce any extraneous solutions. Finally, let's discuss roots of rational functions. Say we have a rational function, f of x is equal to x squared minus x minus 12 divided by x minus 7. To find the roots of this function, or when the function is 0, all we need to do is figure out when the numerator is 0. So we want to solve the equation x squared minus x minus 12 equals 0. But we can just factor x squared minus x minus 12. It's x minus 4 times x plus 3. So the roots of this function f are x equals 4 and minus 3. Although don't forget to check that the function is actually defined at these points. In this case, the denominator is x minus 7, so for values of x equals 4 and minus 3, it will not be 0, so this works.